What's going on, Internet? My name's Ron, and today we're going to continue our series on master keying. Alright guys, last time we talked about shoebox master keying and why that's a bad idea. Today we're going to go over another way of master keying so that we can ensure that only 2 keys fit any one lock. The method we're going to talk about today is only using a single master wafer. And to do that, you're going to need the ability to cut your own keys. We've got a machine over here I'm going to get set up here in a minute, and I'll show it to you. But what we're going to do is only put one master wafer in one cylinder. And in doing that, only 2 keys can fit that one lock. I've got it drawn out here on paper, but let's get these keys cut, and then we're actually going to key up a lock, and maybe some of these numbers will make more sense to you. Give me a minute to get the cameras reset. We'll see you then. Alright guys, what I got here is the Framin 2 key cutting machine. We're going to cut a couple of Schlage keys for our example today. We're going to get this key in here, and what this machine allows you to do is dial back and forth to the nearest thousandth and dial in and out to the nearest thousandth. And now this machine comes with a book that tells you how all keys are cut, the depths and the spaces. I've got it drawn out up here what we're going to cut today. So I'm going to turn this on, and I'm going to dial in and cut one cut at a time on our master key, and then I'm going to dial in and cut one cut at a time on our user key. The machine's pretty noisy. You're probably not going to be able to hear me, so I'm not going to say anything, but here we go. There we have it, guys. 2 different keys cut on the Framin 2 key cutting machine. I'm going to go back over to the desk and show you how to key these up. Alright guys, we got our keys cut. This is the book that I was talking about, and here's the information on how to make a Schlage key. We've got 9 different depths, and these numbers are to the nearest thousandth. And then we've got 6 spaces. We only used 5 today, starting at 231 thousandths, working our way up to 856 thousandths. And it tells you everything you need to know about cutting a key, including the key blank to use, where your starting point's at, which is 231 thousandths, how much space is in between each space, or how many thousandths is between each space, 156, and then the 15 thousandths is the amount between each depth. So we use this book. This book's got literally everything. I can cut just about any key on that machine. That is a manual machine. I do also have a computer operated machine. So we're going to get this out of here, and we're going to go back to this. And we're going to go to the Schlage page. And this method of master keying that I'm going to show you today, using a Schlage key, using one master wafer per chamber, you can get 35 different change keys out of this set using one master key before you start duplicating. Using Schlage, you can get 29. So you're not going to get a lot of doors with this method, but it is the safest, most secure method using standard keys. So we're going to show you how to key up a lock. I had it all laid out here. I see that I've stirred my pins a little bit. We're going to get that straightened up here, and then I'm going to show you how to key up this brand new Schlage cylinder to fit the 2 keys that we just cut on the Framin. So let me straighten up my pins here, and I'll get right back with you guys. All right, guys, we've got our master key, and we've got this Schlage cylinder here. We're going to drop these pins in here. We cut this right off of this sheet here. The master key is a 34540. So we're going to drop these pins in here. 3, 4, 5, 4, 0. And that's all flush at the top of the key. I'm going to put this in the lock, show you that it works. That turns smoothly, comes in and out, turns smoothly. And what I want to show you here is that our change key does not work this lock. Okay, so the master key works fine. So we're going to take this back out, shove our follower through, try not to dump our pins. And what we're going to do now, I cut the first change key on the list, which is a 54540. And what I did is I increased this 3 by 2. You never want to use a smaller master wafer than a number 2. We'll go over that someday on another video. It's just too thin, it gets lost in the lock. So the change key that I cut was this 54520. The last 4 digits are exactly the same. We've increased the first chamber by 2. So we're going to drop a number 2 master wafer in the very first cylinder. Get it to lay flat. And we're going to put this back in the lock. Alright, so it's locked up. We're going to take our master key. Our master key works the lock now. And now the key that didn't work moments ago also works the lock. And that is single chamber master keying. That is the safest way to do it. If you've got a small master keying job where you don't need hundreds and hundreds of doors, this is the way you should do it. Especially if you're not familiar with an existing master key system, this is the safe way. So, hope you learned something, guys. That's all I got for you today. We are going to continue this on and get more and more in-depth into how master keying works, how the mathematics work. We're going to work our way all the way up to a 64-door master key system with sub-master keys. And then we're going to talk about a spreadsheet that I've put together that does all of this for me automatically. All I've got to do is type in your master key bidding, and this spreadsheet lays out, it'll actually lay out something like 60,000 different doors for me. It's a spreadsheet that I built, I put together. I'm looking at ways to offer it to you guys. I haven't quite got that all figured out yet, but hopefully by the time we get to that point in the video series, I'll have that figured out. So that's all I got for you today, guys. Thanks for watching.